So we want to solve this equation for values of x between 0 and pi by 2. And if we look in here, initially we're solving for 3x minus pi by 4. So 3x would be between 0 and 3 pi by 2. And 3x take away pi by 4 would need to be between negative pi by 4 and 6 pi by 4 take away pi by 4 is 5 pi by 4. So then we have the sine of 3x take away pi by 4 is equal to 3/4. And so we need a principal value for that. So that's going to be the inverse sine of 3/4. And so we'll bring the calculator in to do that. I just need to make sure I'm in radian mode. So that's mode 4. And then the inverse sine of 3/4 is 0.8481. Okay, so that gets us started on our cast diagram. So ASTC, so 0.8481 here. It's a sine and it's positive, so the other one would be over here, 0.8481. And so we're looking from negative pi by 4 through to 5 pi by 4, which is there. So we're going to pick up two solutions when we go between those two. So our first one, and remember we're solving here for 3x take away pi by 4. Our first one is going to be at 0.8481. And then the second one will be at pi take away that. So pi take away 0.8481, 2.2935. Okay, so for 3x we now just need to add pi by 4 to each of those solutions. Let's just bring the calculator over here. So 0.8481 add pi by 4, 1.633, I think it was 6335, and then we've got 2.2935, and we'll add pi by 4 to that. That's 3.0789. And then for x we just divide those by 3. So 1.6335 divided by 3. We'll call that 0.54. And 3.0789, divide that by 3, we'll call that 1.03. And I'm giving those two decimal places. And I'll just point out before I go on that the mark scheme actually wanted these to 3 significant figures. I might have actually dropped a mark there by not doing that. So just be careful. 2 decimal places for this first one. This one is 3 significant figures, obviously, but that might have cost me a mark. May not have done. So 3 significant figures I think you should always take as a sort of a minimum. Anyhow, let's move on to this one. So we've got 2 tan squared y plus sec squared y is 14 sec y plus 3. So I think we need to convert this tan squared using tan squared y plus 1 is equal to sec squared y. We need to convert that into a sec squared, and then we'll get a quadratic in sec squared. So that means that tan squared y is sec squared y take away 1. So we'll have 2 sec squared y take away 1 plus sec squared y is equal to 14 sec y plus 3. So that's 2 sec squared y take away 2 plus sec squared y is equal to 14 sec y plus 3. So 3 sec squared y take away 14 sec y take away 5 is equal to 0. And I think there's a chance we might be able to factorize that. So 3 sec y has to be 3 there because 3 is obviously a prime. Now to get to 14, if we put the 5 over here and a 1 here, and make that one a minus and that one a plus, I think that does the trick. And this one would then give us sec y is equal to negative 1/3, and this one gives us sec y equals 5. And of course this one is actually not possible because the sec is only either more than 1 or less than negative 1. So we're only going to get solutions from this one, and that means that cos y, remember cos is 1 over sec, is 1/5. So y is going to be the inverse cosine of 1/5. That's the principal value, obviously. And my calculator currently is in radian mode, so I need to be careful because this question is in degrees. So let's go for degrees. And then I want the inverse cosine of 1/5. And that gives me 78.463. So ASTC, we're going from 0 to 360, so the first one is there. And because we have a positive cosine, the other one is there. So our angles are 78.5 degrees. That is 3 significant figures. And the other one is going to be a 360 take away. So we've got 360 take away my last answer, and we'll call that 282 degrees. And I'll say those are 3 significant figures.